Hey everyone, in this demo I want to show you how easy it is to start protecting your Microsoft Azure Kubernetes Services applications with Kasten K10. So as you can see here that we have our 3-node cluster. We can see that we're using an OS image of Ubuntu and that we're using a container runtime containerd. If we take a quick look at what we have going on from a namespace point of view, you can see that we've got all of the defaults, but we've also got this new Kasten-IO, and that's because Kasten lives within the same Kubernetes cluster and takes advantage of all of the Kubernetes APIs that enables us to take those important snapshots and exports of the data that we're trying to protect. What you can also see here, and we're going to see this later, is our very important mission critical workload, Pac-Man. Now this is a NodeJS front end that you're going to see shortly, but also a MongoDB storing those mission critical high scores. So just to double down again into what that looks like. So if we take a look at the Pac-Man pods, you can simply see that we have the Pac-Man, the Node.js, and the Mongo pod running in the background. So you can see it's not been up for very long, but we've already managed to get some pretty impressive high scores in there. So more on that as before. We're going to just run through the Kasten K10 dashboard. So up here, when you launch the gateway or when you get access to the web interface, either via port forwarding or through load balancing, especially from an Azure point of view, then we get access to this after token authentication and all of the secure access routes that are available. We see these first 3 cards, and the first card is around applications. Now this is going to dynamically discover any of those applications that we just saw in your Kubernetes cluster that may or may not require that level of protection on that data. So as you can see here that we have our Pac-Man application, and if we head back, we've then got policies. Policies is where we create what we want that to look like, automating the data management and what that schedule looks like in order to create that and adhere to those SLAs that you have within your business. So if we take a look at a policy that we have created already for that Pac-Man application, you can see that we have a name. We're choosing an action of snapshot. Imports are around the restore functionality of being able to bring back applications into different clusters from different locations. We have our backup frequency, and we also have the ability to enable backups via Snapshot Export. So this is about, we're going to obviously use the native underlying storage available to create snapshots, but then we've also got the ability to extend that insurance policy by sending that out into object storage. And here you can see that I'm using an Azure location profile, and I'll go into a little bit more detail about that as well shortly. Then we've got a few more granular options around, well, what do you want to do, exporting the snapshot data or just the references. We've got the ability to select the applications by name or by labels. We've got the ability to then be quite granular on what the application resources we want to protect. So in this instance, I want to protect it all, but it might be that I don't want to protect the secrets, or I don't want to protect the services. Then you've got the ability to protect cluster scope resources, so CRDs, cluster role bindings, etc. And then for some of our applications out there, we have the ability to use Canister, which is an application framework, an open source application framework that enables us to take an application consistent backup of our application, of our databases, but also some other services that require that consistency. And then finally, just on the dashboard, we also have this card that gives us a highlight of what our data usage looks like. So where we're using that snapshot piece, where we're defining that in our policies, whether we're using object storage, but then also what the live storage looks like and how we're tracking when it comes to using that storage, so that you get a good, just a very quick view of what that looks like. Now, just to finish off a little tour of the dashboard, we have our activity, so you can see previous backup jobs, whether they're running, they're completed, or they've failed, and then the actions of the last 24 hours. So you can see here that we've got some restores, we've got some exports, etc. So I mentioned around the location profile. So we've got the ability to be able to export those backups out into object storage. For the purpose of this demo, I'm sending those backups out to Azure storage. So Azure Blob Storage. I've provided my storage account name, my storage access key, the location of which I want to store that. Generally, what we're seeing out there is customers using a different region to where their production applications are running for obvious reasons around being able to protect that data in an off-site location. And then you choose the container that you wish to export that to. So pretty basic overview in the time that we've got here on the demo. Let's take a look at the application that we want to protect. So obviously the Pac-Man front end, I'd love to sit through here and have you all watch, but ultimately I've already spent far too much time on this game and on this demo. So if we dive in, you can see that we've got our high scores. Let's simulate this as mission critical data within a database, in that Mongo database that we mentioned before. Now, there's a lot of different failure scenarios that we can run here. If I jump down into MongoDB Compass, select our database, let's say that we want to just change that to ransomware as the user of the just simulating a malicious activity from within the business, for example. And if we now go back to our high scores, you can see that ransomware has taken the top spot and he has the best score in the house. Now what I'm going to do is I'm going to simulate a recovery of just the data. So let's take that last command that we have and put a run on there. So if we go back to the dashboard, we go back to the applications and into our Pac-Man, we see our restore scenarios or our restore points. And within here, the blue one is our snapshot, which is fine for this instance, providing you've captured that data. And the export is what's coming from our Azure object storage. So for the purpose of quickness for the demo, I want to just quickly run through this restore point. So what we've got here is we're going to choose our restore point like we just have. We're going to choose where we want to push this data back. Now, this is interesting because it might be that we're not aware of what else could have changed. We're aware that ransomware was able to change the name of that one line item, but they could have changed and manipulated other things within our application and maybe left other areas. So it might be that instead of restoring everything back into the live production application, let's create a new namespace, maybe Pac-Man clone, maybe Pac-Man investigation, and then we've got the ability to then go and run some more detailed analysis against that. Then we've got some optional restore settings, and for the purpose of time, I just want to do a data-only restore, but you've got other options in there. And the one that I want to flag that I won't use in this instance, but if you're bringing Kubernetes applications from different clouds, different application, different clusters, then you're likely going to have different constructs or different infrastructure underneath, such as storage class. One of the key benefits and differentiators that Kasten K10 has is the ability to transform the recovery portion of that. So as an example, if we want to change the storage class as part of that recovery process, we can absolutely do that. If you're coming from storage class gold and you're coming to Azure file or Azure disk, or even inside AKS, and you want to go from file to disk or vice versa, then this is a great way of being able to migrate those workloads quickly and efficiently between them. So I just want to keep it as that data only. I want to choose the artifact. I'm going to leave everything on there because I only really want the data, and we can kick that off. Now, if we go and look at what's going on here, you're going to start to see those pods change, and what we're going to see after that is, so you see now that we're terminating, and what we're going to see is that recovery process start to take place. And this takes about 30 seconds to recover that small amount of data from the storage snapshot. What we can also do is jump back into the dashboard here, and you can see here that we've started that process of recovery. So here we go. So you can see that the Pac-Man pod is now back up and running. So if we go up here, we could probably start playing some Pac-Man. Great stuff. But let's forget about that. But you can see that our high scores aren't quite ready yet. They haven't quite come up. So we can see that the Mongo pod is now container creating. And I know that this takes about another 15 seconds to bring up. And there we go. There, we have everything running. So if we head back to Pac-Man now and just hit back and hit our high scores, you can see now that that ransomware, that name, that change is now back into where it needs to be. Hopefully that was useful. If there's any questions, please ask us. Always happy to help. Thank you.